I would like to go over a few more examples from today's lesson. One of the concepts that we talked about is finding the x and y intercepts of a graph, of an equation. And as you know, to find the intercepts, you have to be plugging in zeros. To find the x-intercept, you have to let y equal 0 and then solve the equation for x. To find y-intercepts, you let x equal 0 and solve the equation for y. In other words, you're going to end up for the x-intercepts, you're going to end up with points that are of the form something, comma, 0. And for the y-intercepts, you'll have the opposite. You'll end up with points that are of the form 0, comma, something. That's why you have to plug in 0 for y to get x, to find the x-intercepts, and plug in 0 for x to get the y-intercepts. All right, let's do one of the examples. The first one is number 50. I'm doing the evens because the odds and answers are in the back of the book. The first thing that you're going to do is we're going to find the x-intercept by plugging in 0 for y. So if you plug in 0 for y, copy down the rest of the problem, you will be able to solve for x, and that will give you the x-intercept or intercepts. There may be more than one. To find the y-intercept, you're going to plug in 0 for x. Now, both of these equations, you should have the skills to be able to solve. I'm going to solve this one first because it's a little bit easier. Y equals, now using the order of operations, that's 3 to the second power. So y equals 9. Therefore, the y-intercept is the point 0, comma 9. Now over here, it's a little bit more complicated. There's a few ways to solve this. One of the ways is to FOIL this out, and you'll have a quadratic equation that you would then solve. But if you think about it, it's already in factored form. I'm going to take the square root of both sides of the equation. So you get 0 equals x plus 3. So if you subtract 3 on both sides, you end up with your x equals negative 3. Now, that means that the x-intercept is negative 3, 0. Okay, so those are your intercepts for this graph. Now, what does that really look like? I'm going to bring over my graphing calculator right here, and I've already typed in several of the equations that I'm going to work on today. Notice these ones are not highlighted, so the graph is only going to graph this first one. If I graph this on a Zoom 6 standard window, this is what it looks like. Can you tell where the intercepts are? This intercept right here, the x-intercept, is at negative 3, 0, just like we showed. And then this one, 0, 9, is the y-intercept. So these are reasonable answers for what we have. All right, let's go on to the next problem. The next problem, we have a radical equation. So we're going to do the same process. First thing we're going to do is we're going to substitute 0 for y, which will allow us to find the x-intercept. Oops, excuse me, that's not the right one. Okay, leave that as x. And then on the other side, we're going to plug in 0 for x and solve for y, and that will allow us to find the y-intercept. Now be careful, you don't want to plug in 0 for both because unless the graph goes through the origin, that doesn't make any sense. Okay, what I'm going to do is on this one, to solve for x, as you remember, you have to crack the lobster shell. So we're going to square both sides because that will help us get into that lobster shell. The squared and the square root cancel out, and you'll just be left with 2x minus 1. Of course, 0 squared is 0, so that makes it kind of easy. Next, you're going to add 1 to both sides. I'm not going to show the work because you've all passed Algebra 1. And divide by 2 on both sides. So you'll end up with x equals 1/2. All right, now that means, since x equals 1/2, that means the the x-intercept is 1/2, 0. Okay, let's solve this one. So, simplify, excuse me. 2 times 0 is 0, and then negative 1. 0 subtract 1. Now, you have a negative 1 under the radical. What does that mean? Well, we have learned about this. This means 1i, but because we're graphing on a real number plane, we're not going to have, that's not going to be a solution that will be graphable. So if we're looking for intercepts on the graph, this will not be one of them because we can't graph imaginary numbers, complex numbers, on a real number graph. Okay, so I'm going to go over here. I'm going to unhighlight that graph so that it's just going to graph the square root graph. Highlight that one. Graph on the same standard window, and you can see right here that it's the square root shape. Now right here in the middle you can see that 1/2 0 is a reasonable estimate. So I'm going to zoom in just on this little section so that you can see that it does, in fact, there is a place where if you follow this down, it does go through the x-axis at 1/2. However, notice that it never goes through the y-axis. It's just going to go up to the right. It never goes through the y-axis, which is why when we look over here, there is no real number for the y value of the y-intercept. Okay, let's do another one. So far we've done quadratic and we did square roots, so now we need to do absolute value. So same thing, we're going to start it out the same way. We're going to start it out by plugging in 0 for y. Alright, so here we go. Alright, and then we're going to plug in 0 for x, and that will allow us to find the intercepts. I'm going to do this one first because, you know, it always seems to be easier this way. Alright, 0 plus 10 is, of course, 10. Now the absolute value of 10 is 10, but then if you apply the negative afterward, that will be negative 10. So the y-intercept will be 0, negative 10. Okay, over here, with this negative, you can basically cancel that out, because if you think of that as like a negative 1, you can divide out the negative 1 on both sides. It's basically just, it just goes away. So 0 equals absolute value of x plus 10. Now, usually with absolute value equations, you have to separate it into the regular equation and the evil twin. But since the regular equation and the evil twin, all they do is they change this number here to positive versus negative. And since that's 0, it's not going to matter, because if you have x plus 10 equals 0, and then for your evil twin equation, you try to do x plus 10 equals negative 0, there is no such thing as a negative 0. So that doesn't even make sense. So really, this is an easy one. You only have to solve this. So we'll subtract 10 from both sides, and we'll get x equals negative 10. So the solution is the x-intercept is negative 10, 0. Now, if we graph this, we should see that those are the only intercepts that are there. So I'm going to go back to my graphing calculator, go back into y equals. I've just worked with this equation. I'm going to unhighlight that, deselect it, and go to the third one. I'm going to select that to be graphed. And if I graph that on my standard window, oh, whoops, it's not in a standard window right now. So I have to go back to Zoom 6, Zoom Standard, because otherwise it won't show it. Now, even though we know that this is an absolute value graph and that it should have a V shape, we can't see the full graph, but we can see that it goes through negative 10 on the x-axis and negative 10 on the y-axis. I'm going to zoom out just so that you can see the rest of the graph, so that you can see that it does have that, familiar V shape. All right, here we go. So you can see that it's the V shape, but the intercepts, there's only the two intercepts. There's this intercept on the x-axis and this intercept on the y-axis, and that's all that we have. Well, I hope this helped out a little bit.